We are inside the OWASP Top 10 from 2021 module on TryHackMe, which is part of the complete beginner path that we are doing. Task number 20, data integrity failures. Data integrity failures. Let's think of how web applications maintain sessions. Usually when a user logs into an application, they will be assigned some sort of session token that will need to be saved on the browser for as long as the session lasts. This token will be repeated on each subsequent request so that the web application knows who we are. These session tokens can come in many forms but are usually assigned via cookies. Cookies are value key pairs that a web application will store on the user's browser, and that will be automatically repeated on each request to the website that issued them. Here we see an example of a cookie value and a pair. For example, if you were creating a webmail application, you're going to assign a cookie to each user after logging in that contains their username. In subsequent requests, your browser would always send your username in the cookie so that your web application knows what user is connecting. This would be a terrible idea security-wise because, as we mentioned, cookies are stored on the user's browser. So if the user tampers with the cookie and changes the username, they could potentially impersonate someone else and read their emails. This application will suffer from a data integrity failures, as it trusts data that an attacker can tamper with. One solution to this is to use some integrity mechanisms to guarantee that the cookie hasn't been altered by the user. To avoid reinventing the wheel, we could use some token implementations that allow you to do this and deal with all of the cryptography to provide proof of integrity without you having to bother with it. One such implementation is JSON Web Tokens, or JWT. JWTs are very simple tokens that allow you to store key value pairs on a token that provides integrity as part of the token. The idea is that you can generate tokens that you can give your users with the certainty that they won't be able to alter the key value pair and pass the integrity check. The structure of a JWT token is formed of three parts. We have the header, the payload, and the signature. The header contains metadata indicating this is a JSON web token, and the sign-in algorithm is used SH256. The payload contains the key value pairs with the data that the web applications wants the client to store. The signature is similar to a hash taken to verify the payload's integrity. If you change the payload, the web application can verify that the signature won't match and know that you tampered with the JWT. Unlike a simple hash, this signature involves the use of a secret key held by the server only, which means that if you change the payload, you won't be able to generate the matching signature unless you know the secret key. Notice that each of three parts of the token is simply plain text encoded with base64. We can use this online tool, this encoder and decoder in our case. Try to decode the header and payload of the... Okay, let's try this. We'll try to decode. So as you can see, we actually tried base64 decode org, and we see basically the same things that we see on TryHackMe. This information is basically seen after we decode the token, the JWT token. But even if we see this information, note the signature contains binary data, so even if you decode it, you won't be able to make much sense of it anyways. JWT and the non-algorithm. A data integrity failure vulnerability was present on some libraries implementing JWTs a while ago. As we have seen, JWT implements a signature to validate the integrity of the payload data. The vulnerable libraries allow attackers to bypass the signature validation by changing the two following things in JWT. Modifying the header section of the token so that the ALG header would contain the value of none and remove the signature part. Taking the JWT from before as an example, if you wanted to change the payload so that the user becomes admin and no signature check is done, we would have to decode the header and payload, modify them as needed, and encode them back. Yeah. Notice how we remove the signature. So basically, as you can see here in the header and the payload, we don't have the third part, the signature part, because in the header for ALG, we set none instead of this HS256, and for the username, basically we set admin. And now we can log in with admin. It sounds pretty simple. Let's walk through the process an attacker would have to follow in an example scenario. Navigate to our vulnerable IP address and follow the instructions in the questions below. Okay, let's do that. All right, so we have the website. Let's press, let's say here, Arthur, and the password, whatever, 1, 2, 3, 4. We go for login. And we see invalid credentials. You can also log in as guest with password guests. Okay, so we go. Actually, first let's inspect. Open inspect. We go to network. We leave it like here, and we say guest. And we say guest. For this, we need a valid account because perfect. Here we see login flag because we need a cookie. As you can see here, we have the JWT session and we have to encode that. Amazing. We paste it here in a new tab, then dot. We take the last part and we do the same with the admin. We encode. We take the last part. Boom. And we also place a dot at the end. We go over here. We paste the value right and we refresh. There you go. Here it is. So answer the questions below. Try logging into the application as guest. What is the guest account password? Is guest. Actually, let me paste all of this and then I will explain what I did. Yes, correct. Okay. Now, if we go all the way back to the vulnerable application, you will be prompted with this. Actually, let me expand. You will prompted with this login. If, for instance, you say here Batman and Cave, say login, you will say invalid credentials. You can also log in as guest with password guest. Cool. We go guest. We say login. Amazing. Hello guest. Only the admin user is allowed to get the flag. Cool. Now we go right click inspect. Developer console is on. We can go to network. Here we can inspect. If we refresh the page, we can inspect for our get method. We can inspect the request headers and we see our JWT session cookie. But let's jump into the storage. And here we can see the same cookie here. Now, this cookie we copy. Okay, and when we paste it here and say decode, we can see that the 3 section of our token, right? We see the header, we see the payload, and we see the signature. Now we copy this, we go into encode. We paste it here. We don't need the last part, which is the signature. And we go inside our payload. For the guest, we say admin. And for algo, we say none. Let's see if we place. Let me see if it works if I place here the dots. Okay, so now if we encode this information, you will get this entire thing, right? But when we check again our cookie, you can see that, let me show you actually. You know what? In order to show you better, I will copy this and I will open the Sublime text. Paste it over here and I will increase the font. So as you can see in our JSON session token on the browser, we see the header divided by a dot, then the payload divided by a dot, then the signature. Now, in order to log in as guest and see the flag, we still have to divide the header, this header, actually this header, to the payload. We have to divide them by dots. After that, we go back in our guest session. We paste here the payload and then we refresh the page. Then the application will see us as admin. And we can successfully complete our data integrity vulnerability, data integrity failures, to be more specific. Awesome. For tomorrow, we have security logging and monitoring failures. I can't wait. So for that, stay tuned.